So, when you're in the middle of a massive industrial project, what's one of the most crucial decisions that often gets overlooked? Believe it or not, it's choosing the right electrical wire. It sounds simple, but getting this wrong, well, the consequences can be catastrophic. Let's break down exactly why. So, do you think all wires are pretty much the same? I mean, it's a common assumption, right? If it's the right size, it's the right wire. But in an industrial setting, that is a seriously dangerous oversimplification. The stakes, we're talking everything from equipment failure to major safety hazards, are just on a completely different planet. Just think for a second about the difference between your home and a factory. At home, you've got relatively low voltage for your lights and appliances. A factory, though, that's a whole other world. You've got high voltage, constant vibration, heavy machinery. The electrical demands are just worlds apart. And the wiring has to be too. Okay, so what really makes these industrial demands so different? It's not just about getting a charge from point A to point B. It's about pure survival in some of the toughest conditions you can imagine. An industrial wire is under constant assaults. I mean, heavy currents are generating intense heat from the inside, while the factory environment is throwing its own heat, moisture, and corrosive chemicals at it from the outside. And on top of all that, there's the constant risk of physical damage, from abrasion or impacts. A standard wire just can't survive that kind of beating. So, how do you fight back against all those harsh conditions? Well, you need a specialized toolkit. Forget one size fits all. We're talking about a whole menu of wire options, where each one is designed like a specific tool for a very specific job. All right, let's open up that toolkit and see what we've got. It all starts with the conductor. Reliable copper is pretty much the gold standard, but lighter aluminum can be a great budget-friendly alternative. Then you've got the armor, the insulation. Basic PVC is a good all-rounder for most things, but for extreme heat, you need XLPE. Think of it like a firefighter's coat for your wire. For flexibility in wet places, you'd grab EPR. And there are even specialized defenses, like shielded wires to block signal interference, or LSZH, that's low smoke zero halogen, which is absolutely critical for fire safety. So with all these specialized tools, how do you actually pick the right one? It might seem a little complex, but it really all boils down to a clear, practical 4-point checklist that'll help you make the right call every single time. So here's the thought process. First up, you've got to consider the electrical load. Can the wire handle the current and voltage without overheating? Next, look at the environment. You have to match the insulation to any threats out there, like heat or chemicals. Then, and this is non-negotiable, you absolutely must make sure it complies with safety standards, like those from bodies like IEC or UL. And finally, what's its job? A wire carrying massive power is built totally different than one carrying a tiny, sensitive control signal. Let's put that thinking into practice with a classic decision: solid versus stranded wire. This is one of the most common choices an engineer makes, and it's a perfect example of a trade-off. In this case, it's all about rigidity versus flexibility. This brings us to the core dilemma, right? Do you need the unyielding strength of a solid core, or is flexibility the top priority? The right answer really comes down to just one thing: where and how that wire is going to be used. Solid wire gives you incredible mechanical strength. That makes it perfect for permanent, straight runs inside an electrical panel where it's never going to be disturbed. But for anything that moves, bends, or vibrates, like a robotic arm or machine on the factory floor, stranded wire is the only way to go. Its flexibility is literally designed to withstand constant motion. So let's bring it all home with a final showdown and recap that huge gap that separates the world of industrial wiring from its everyday residential cousin. When you see them side by side like this, the contrast is just stark. Industrial wire is engineered for high voltage and brute strength, with thick, tough insulation made for heavy machinery. Residential wire is so much simpler, designed for that low voltage world of lights and appliances. They are truly built for two completely different universes. Okay, so what's a solid, reliable starting point for most of your projects? Well, a copper conductor is almost always the right call. If you pair that with a durable PVC or a high-resistance XLP insulation, you've got a really powerful combination that can handle a huge range of industrial demands. So now you have the framework. You know to think about the load, the environment, the application. The real question I'll leave you with is this: in your world, what's the one hazard, the heat, the chemicals, the vibration, that's the toughest nut for you to crack? Thanks for tuning in.